Hello students, welcome to Physics Patsala. Today we'll study on significant figure. Significant figure is linked to our measurement. As we have discussed, every measurement is associated with certain error. Error is certain uncertain. Error is some uncertain values. That means our measured value will have some certain digits and some uncertain digits. That means in each measurement, the certain digit or fixed digit will remain same. For this uncertain digital variable varying digits will keep on varying. This will be giving error. This is the root cause of error. Now, to minimize error so that we can have our measured value very nearer to the true value of the quantity, we'll use significant figure. That means significant figure will consider or consist all certain digits plus one uncertain digit. This will become significant figure, or right, SF. Now it is clear for every measured value, or while we do any measurement for any physical quantity, we'll get some result. In that result, we'll get certain fixed digits. Along with that, some uncertain digits or some varying digits. In each measurement, this uncertain digit will vary. The uncertain digits, one digit we are taking, and all remaining certain digits we are taking. Combine this all certain digit and one uncertain digit gives the significant figure for that measured value. Measured value. This will be nearer to the true value of the item. Now we have certain rules to find out significant figure. In significant figure, we will be studying what are the rules to find out significant figure and what is the significant figure of the result of different quantities, if they are added or subtracted, or if they are multiplied or divided. In that case, what will be significant figure? If two quantities are added, what will be significant figure of result of the result? If two quantities are multiplied, divided, what is significant of the result? That we'll study. Before that, if any number is given or any measurement is being done for a particular measurement, once we got some value or digits, what is the significant figure of any measured value. For that we have rules. Are these rules? We have six rules. Let us study these rules. Rules for to find out significant figure. Suppose any measurement we found 1, 2, 3, 4. The number consists of these four digits 1, 2, 3, 4. Then significant figure for this number will be 4. How? Suppose in another measurement we got 1, 0, 2, 3, 4. In that significant figure will be 5. Suppose in another measurement we got 1, 0, 2, 3, 0. In that significant figure will be 4. Suppose we have one measurement 1, 0, 2, 0, 0. Significant figure will be 3. Suppose we have one measurement 1, 0, 0, 2, 3. Significant figure will be 5. Suppose we have one measurement and that it is 0.001. In that significant figure will be 1. If any measurement 0.003, significant figure again 1. If any measurement 0.0103, significant figure will be 3. Suppose we have 0.01030, significant figure will be 4. Suppose we have one number 3.012, significant figure will be 4. If number is 30120, significant figure will be 6. Suppose any number we have 0.01200, significant figure will be 7. How we got all these different types? Using this rule, rule 1 says all all non-zero digits are significant. Here, all non-zero and significant. Second rule says all zeros between non-zero digits are significant. Here, this 0 became significant. Third says all leading or leading or starting zeros are not significant. Here, left side zeros are not significant. If a number is 0.312, significant figure will be 3, because this again all leading or starting zeros non-significant. Now trailing or last zeros. Trailing or end zeros. Here we'll have two options. If it is decimal number, then significant. If non-decimal number, then non-significant. Here, this non-decimal, this is again non-decimal. Here it is decimal, hence this is significant. Here it is after decimal, it is significant. Here it is after decimal, it is significant. Rule fifth says exponential term. Exponential term. Exponential or exponential or power of 10. Power of 10 will contribute nil. Will not be considered. Will not be considered for significant figure. For example, we have 3 into 10 to the power 3 meter. Here significant figure is this contributes nil, hence this only 1. If it is 3.0 into 10 to the power 3 meter, again significant figure becomes 3.0. 2. This 0 is significant, this is also significant. If it is 3 into 10 to the power 1 kilometer, again 10 to the 1 carries no contribution, hence significant figure is 1. These two terms are equivalent. Whether it is 3 into 10 to the 1 kilometer or 3 into here you can say 3 into 10 to the power 0, that's 3 kilometer. Here 3 kilometer equal to 3 into 10 to the power 3 meter. In both case, significant figure is 1. This significant figure is considered by this digit 3 only. After these rules for to find out significant figure, we will be studying for significant figure, rules to find out significant figure. Another is arithmetic operation, that is addition, subtraction of numbers, or multiplication or division of numbers. In those cases, what will be the significant figure of the result? Of the result. If two numbers are added, when do we get result? What is the significant figure of this result. Now, another one will study is rounding off the significant figure. That means the result which we got will be rounding off just to have our value nearest to the true value of the measured quantity, or we'll have less error. We'll be studying rounding off arithmetic operation rules we have studied. Now, second part is arithmetic operation. Will if two quantities are multiplied and we get a result, suppose any quantity x is there and it is the multiplication of quantity a and b, then in that case what you'll do to find out significant figure, step says do the normal algebraic multiplication or division of numbers a and b. Now, find second point step is find least significant figure number. Identify identify least significant number and its significant figure value out of a and b. We have two numbers a and b. Suppose a has significant figure 3 and b has significant figure 4. That means 3 is have least significant figure or less significant figure than 4. Then implement this least significant figure, this significant figure of this least significant figure, implement this significant figure value of least significant figure in final result. Now result will have significant figure 3. Suppose we have a 3.02 and b has 3.1. Once we multiply it, we get, suppose in first using first step we'll do normal algebraic multiplication and result will be uh, 0 2 then 3 6 9 2 6 3 9. It became this 3.02 and okay, now it became 9.3 362. Here significant figure is 3. Here significant figure is 2. We'll take significant for the result as 2 because this is the least one. Hence we'll go up to 9.3. This will be our result. We'll have number of examples to find out how to get the significant of the results if two terms are multiplied. Now here we will be doing another thing is rounding off will be used because here 2 will be taken and this will be dropped. In that case, we'll implement the rules for rounding off of the significant figure. Rounding of significant figure, say here instead of 9.3, the result will be 9.4. We'll study now how this became 9.4 using this rounding off. Before studying arithmetic addition subtraction of significant figures, let us study rounding off. Rounding off of significant figures. That means if any digit to be dropped, suppose any result is 2, 3, 6 and we have to round off to its nearest 3 significant figure. Here significant is 4. Here significant is 4 for this number. But we want to round up to nearest 3 significant figure. That means 3 result in that result it will be 3, 2, 3. This will be dropped. And this should be answer this. But to have very nearer answer, accurate answer, we'll be using different rules of rounding off. Now, rule 1 says if the number to be dropped is greater than 5, then the previous digit to be increased by 1. Previous digit to be increased by 1. If the digit to be dropped is less than 5, then previous digit will be no change. No change in previous digit. Rule 3 says if the here is drop digit. If the digit to be dropped is equal to 5, then check follow digit. Check follow digits. That is digit after in here 6 was last one. If in another case say after 6 suppose we get 2. Any digit there that is 2 is here follow digit. 3 is here previous digit and 6 is the dropped digit. We have to check follow digit. If follow digit is non-zero, then previous digit will be increased by 1. If follow digit is 0 or no any digit like it was earlier, after 6 there is no digit, it's no digit case, or if it will be after 6 0 is there. In that case, we have to check again previous digit. Check previous digit. If previous digit is odd or even. If previous digit is odd, then previous digit will be increased by 1. If it is even, there will be no change. No change in previous digit. This is the rules we have to follow while rounding off the significant figure. Now let us take certain examples to understand. Rule 1 says if the drop digit is greater than 5. Let us take certain examples. Number is 3.236 and number is 3.2360 and the number is 2.235. That is 3.235. That is 3.245. Here, as per rule 1, we want and our requirement is we have to round up to 3 nearest significant figure. So in that case, 6 to be dropped. So what the steps? First step is identify drop digit DD. Identify dropped digit. Here in the case, drop digit is 6. We have rounded up. In another, this also this case 5, this case 5, this case 5. In this one, drop digit is greater than 5. Now, while rounding off, then next is identify drop digit, then identify previous digit. Here, previous digit is let's squared up 3. This is drop digit and this is previous digit. Now, rule says if drop digit is greater than 5, like in our case, it is greater than 5. Now, the previous digit will be increased by 1. It was 3, it will become 4. Answer became 3.24. In another case, suppose it is 2.31. In that case, this is our drop digit. This is our previous digit. This to be dropped. That is less than 5. Hence, previous digit will remain unchanged. The result will be, answer will be 3.23. Rule 2. We checked. Now, rule 3 says if the drop digit is 5, if drop digit is 5, what we'll do? Then we'll go to check, find fixed digit, DD. First we identify DD, then PD, then FD. FD to be checked in that case if FD is non-zero. If FD is non-zero, suppose this case it is 3. It is a non-zero case. Then straightway this PD will be PD will be, this is FD, then result 2.2, this PD will be increased by 1. Find FD. If FD is like this, FD is non-zero, that means some value between 1 to 9. FD is 1 to 9. Then in that case, go to PD and increase by 1. We have done it. 3 became 4. If FD is 0, then if FD is 0 in this case, what we will do? We'll go to PD. We'll check PD. Check PD. 0, then check PD. If PD is, if PD is odd, if PD is odd, then PD will be increased by 1. In this case, PD is odd. In this case, PD is odd. Now it will be increased by 1. Suppose in another case, whether it is 0 is there or no number is there, like 0 is there. In that case, if PD is even, this PD is here even, then no change, 3.24. That means PD is even, that means PD no change. Similar way, whether it is 0 is there or no digit there, this rule will be valid. This, in this way, we'll be doing rounding off for all digits. It will be more clear once we'll do number of examples on this rounding off. In next class, we'll be covering significant figure for quantities added or subtracted. That is arithmetic, addition, subtraction. If it is done, what is the significance of the result, that we will study.